Let's derive the formula for a parabola as defined in the notes as a conic section. So we said in the notes that the parabola is the set of all points, P, I'll call it P. P is x and y, so we're going to try to find a formula for the coordinates of, say, this point, x, y, such that the distance between P and the focus is equal to the distance between P and the line L. Okay, so if we draw this, we've got that this line segment and this line segment have the same length. So these two lines should have the same length. Of course, to derive a formula, we need coordinates for this one, HK, and then the equation of the directrix here, L. Let's just say that I've got this set up so that it looks like the directrix is a horizontal directrix. So let's say that y is equal to d, so some number d. Okay, so what we want to do now is work out some formula to derive the formula for the point xy. So can we relate x and y in terms of, say, the x value? All right, let's first start by writing out formulas for these two pieces here, these distances. So if this point, by the way, this point down here, its coordinates are going to be, whatever the x coordinate is, it sits directly below the point. So this is going to be the point x, comma, d, if this is the line y equals d. Okay, now we just work out the distances. So the distance between the point P and F, this is of course given by the distance formula. So that's the square root of x minus h squared plus y minus k squared. It's just Pythagorean theorem. That's the distance there. The length of this curve, we can plug into the distance formula as well if we want to. By the way, this is the point that makes a right angle with the line. That's the closest point. Okay, so this is then the square root of, notice that the x values are the same, so this is x minus x squared plus y minus d squared. Quantity squared. And so these are supposed to be equal to each other. So the equation that we end up with is that the square root x minus h squared plus y minus k squared, this should be equal to the square root of, this term is already squared, or sorry, it's already 0, x minus x is 0, so this just becomes y minus d, quantity squared, and at this point we can square both sides to get rid of the square root. Okay, so I'm going to square both sides and go to a clean sheet of paper here. So after squaring, what we end up with is we have x minus h squared plus y minus k squared should equal y minus d, quantity squared. All right, and then let's just multiply all this out and see what happens. So we can leave this one the way it is, but we'd like to solve for y if possible here. So we'll leave this as x minus h quantity squared, and then this one becomes y squared minus 2ky plus k squared, and on this side it's y squared minus 2dy plus d squared. Okay, and at this point we notice we have these y squareds. Those are going to cancel out, and we can combine all this other stuff on the same side. So we can add this over here, maybe take this over here, and eventually we're going to end up with a formula that looks like a parabola. So here we have, if we move this all over, we end up with 2 times k minus d times y. This should equal x minus h squared plus k squared minus d squared, after rearranging everything. And if we want this to look like a parabola like we're used to, we want to solve for y, we just divide through by this leading coefficient here. And if we go back to our picture, k and d, k is the height of the focus, d is the height in the y direction, so these are both y directions. K is the height in the y direction of the focus, d is the height of the directrix, and of course if these two have the same height, then we're not going to get a parabola out of this. We're just going to get a line anyway. So these two, to get a parabola in the first place, k and d have to be different numbers. They can't be the same number. And so that tells us that this number right here, this number k minus d, this is not 0. So we can divide through, and what we end up with is a formula, and you can decide how much work you want to do to simplify this, but we end up with this formula 1 over 2 times k minus d times x minus h quantity squared plus k squared minus d squared over 2 k minus d. And of course, k squared minus d squared is a difference of squares, so we can actually work that out and figure out what that is, and we'll end up with this formula. So what I mean here is that k, this term right here, just this term, so this is part of our answer, right? But this term factors to be k plus d times k minus d. And so obviously we see we're going to be able to do some cancellation here. So we end up with this formula. Y is equal to 1 over 2 times k minus d in the denominator times x minus h squared plus, after we cancel, we end up with just k plus d over 2 as our constant here. Okay, and so this is the equation of our parabola. And of course, if we write this in a more standard form, we can just kind of regroup, move this one back over, and we end up with y minus k plus d over 2 equals 1 over 2 times k minus d x minus h quantity squared. This is now in a form in what we might call vertex form. This right here is the stretch factor of the parabola, which we usually call a. The h is the h of the vertex, and this whole term right here, this is the k of the vertex. So our parabola has vertex h comma k plus d over 2, and it has a stretch factor or scaling factor 1 over 2 times k minus d.